of you have seen the beginning of a sporting event? Maybe football. Have you ever seen them flip the coin? You know why they're doing that? That's the decision that's made if the team wants to be the first to kick or if they want to go second. And the reason that they use a coin, flipping heads or tails, means there's a 50-50 chance. Two teams, two different options. But let's go a little bit deeper and talk about a probability line. Now, you may have covered this in your mathematics class, but just in case you need a reminder, let's talk about the probability of events. So I'm going to draw a probability line. And if an event is near 0, that means it's unlikely. It's not going to happen. But when you get to 1, that means the event is very likely. It's going to happen. And then halfway through is your 1/2. So it's equally likely and unlikely that that event could happen. Let's break it down a bit more. I can also take these figures on the probability line and turn them into decimals. So that would be 0.0, 0.5, and 1.0. Now let's talk about that in terms of percentages. This would be a 0% chance. This would be a 50% chance. And this is a 100% chance of that event. Then you also have space in between here. So if this is 0 to 50%, 10, 20, 30, 40, 50, then 60, 70, 80, 90, 100. Well, why do I worry about those other pieces? Let's talk about probability with marbles. So in this little container, I have 1 clear marble, 3 green marbles, and 7 blue marbles. So in total, there's 11. I'm going to bring you back to the iPad, and this will help us work some numbers out. So let's talk about the likelihood of me pulling, say, the clear marble. Well, the clear marble is a 1 in 11 chance. In decimal format, that's a 0.09 chance. And percentage-wise, I have a 9% chance that I'm going to pull a clear marble. What about the green? Well, that's 3 out of 11, or 2.66, or 27% chance. Those are better odds. Well, now let's look at the blue marbles. I have 7 out of 11 for that one. That gives me a 0.64 or a 64% chance. So looking at this, I'm curious what my likelihood is of pulling a clear marble. Let's now place that on the number line here. I'd put 9% right about here. The green marble, let's see, that's 10, that's 20, 27% chance here. And the blue, that's 50, that's 60, so 64 would put me right about here. So it is much more likely that I'm going to pull a blue marble than I would a clear marble. So this is how the probability line can help us determine the likelihood of an event. Well, let's talk about number cubes now. So I have a 6-sided number cube or die here. And of course it starts with 1 and runs all the way to 6. So what does that look like? I'm going to pull up a picture for reference here. So when I roll the die, there are 6 sides. So I have a 1 in 6 chance of pulling a 1, a 1 in 6 of rolling a 2, so on and so forth. That also breaks down to 0.166, or when I round that, 17%. So there's a 17% chance that I will roll a 3, a 6, a 2, or a 1. But is that going to happen if I roll my dice exactly 20 times? Well, here's an example of what I did. I didn't want you to have to wait and watch me roll the die 20 times. You'll see that these percentages did not quite work out to 17 across the board. Well, when you increase the frequency of the event, you're going to find that these percentages start to balance out or start to look a lot closer to one another. But before we do that, let's actually create a coding program that turns our code node into a random number generator, essentially turning this 5x5 LED array into a number cube. When I shake it, it'll give me random numbers. All right, so I'm going to bring you to the Spark View screen, and I've already opened up this program, and there's a lot going on here. So let's talk about what we're telling the computer what it is we want it to do. Well, you're first going to see my loop here. So again, this is telling the computer to keep doing these things over and over again until I stop the program. I am setting it to do certain things as long as it's in motion. But what does that exactly look like? Okay, so we are going to turn our code node into a random number generator, or basically turning it into a number cube. The sensor that we're going to be utilizing for this program is the accelerometer, the motion sensor within the code node. And I want to show you what that data looks like up front. So I'm going to click on sensor data. I'm going to disable the temperature, light, and sound sensor. We won't need that. I'm going to disable the magnetic field sensor and choose acceleration X and Y only for this program. And bring up the graph display. So you're going to see on the top, I have acceleration X over time, and then acceleration Y over time. So what does this data look like? I'm going to hit start, and I want you to notice when I lift the code node up and down, you're seeing the different measurements. When I move it back and forth, this is where it's seeing the acceleration X and Y. When I move it up and down, that's where I'm seeing acceleration Y. So both of these measurements are going to be utilized in our program to let us know when the code node is in motion. I'm going to show you the code completed first. I already have it created for you, and then we'll build it together. So I have my loop in here, which is telling me as long as everything is going on, as long as things are in motion, keep running through the program until I hit stop. Then I'm setting it as long as the code node is in motion, it's going to do all of these different things. This piece right here is making sure that I have a delay in there. So in between numbers, the screen will be blank. You'll see that working shortly. And then this is a neat piece here. You're having to create a variable, but you're getting to use the random integers mathematics block. And basically, I'm going to program that to only go 1 through 6. So every time I pick the code node up and shake it and put it down, like I would roll the die, it's going to give me a different number, only 1 through 6. Then you'll see here how I program the 5x5 LED array. I'm actually going to show you a different, easier way to do that when we build this step by step, but I wanted you to see it this way first. I'm going to click start, and you're going to pay attention to the 5x5 LED array on the cube. All right, let's give it a whirl. 3, 3, 4. So you see, as long as I'm picking it up and giving it motion, it's running through the random integer, and it's giving me different numbers almost every time. Sometimes you're going to get duplicates because it's randomized. All right, so let's build this together. And again, don't panic if you miss any parts. You can go back in the video, or you can refer to your book so you know what blocks to choose. So I'm going to be referring to my absolute values and random number cube activity out of the book. All right, just like before, the only sensors I'm going to need here fall under the motion sensor for acceleration X and Y. So I'm going to disable the rest. I chose the line graph, but I'm really not going to need that because all I'm going to be paying attention to is the output on the 5x5 LED array. That's ultimately what we're programming. All right, let's get started. I know I have a variable here, so I want to go ahead and create that up front, and I'm going to name that roll. Good, so that's ready to go. And let's start by building our loop. This is just going to be a basic while true. That's the first step. I'm going to bring in a logic block. And this is the part of the program that's a little bit tough. So I'm going to build it with you. We are going to pull this logic block, comparison block out. But I'm going to want it to say the absolute value of x and the absolute value of y acceleration greater than 20. And I got that when I was testing out my data, moving my code node up and down, just paying attention to those measurements. Absolute value is going to give us a positive number. And that was important because if we're looking at acceleration y or x, dependent on how you're moving that, you could get negative integers. So we're going to correct that here. I'm going to pull out this block again because that's where absolute value lives. And I'm going to say if the absolute value of acceleration x, got that in there. Oh, I just realized I did something. That's why we're doing this together. Within this comparison block, I actually have to go into the math block and pull this guy out. So if the value of absolute value of acceleration x, plug that in there, plus the absolute value of y, remember you just use the drop down arrow, is greater. For this, I want it to read 20. As you're experimenting with your program, you might find different numbers that work for you here, but this is what works for me. As long as it's greater than 20, I want it to clear all and then set the LED array to nothingness. I want it to be dark. So therefore, I haven't given any indicators on the LED array, and I've set it to 0. I do want it to have moments of pause, so I need to pull in another loop here. And I need all this again. So rather than building it again, I'm just going to right-click on it and duplicate this block and pull it in here. I want this value to be a lot lower though. I'm going to make that 10. Again, it's because it's reading the movement that I'm creating as I shake the code node back and forth or up and down. And this is creating a pause. I'll disable this when we run the program again so you can see why this section of the code is really important. All right, now I can recall my variable. I'm going to set the roll, and I need my random integer. So right now it says 1 through 100. Well, my die only has 6 sides, so I'm only going to have it say 1 to 6. So as long as this is going on, I need to pull out logic block again. And if, oops, need my comparison here. If the roll is a 1, and remember I told you I was going to show you a different way to program your 5x5 LED array. You've seen it in lists if you've seen our magnetism activity. But for this, we've got a block that has the layout of that array, and I can just click what I want it to illuminate. So if I roll a 1, I want it just to illuminate that. Now I have to do this for 6 different rolls. There's a very quick way you can do this. You have to click on the gear, and I'm going to say else if. That's for 2, 3, 4. Oops, did I miss it? 1, 2, 3, 4. No, I'm good. 5 and 6. I can duplicate this block multiple times. right click, and then I just have to fix the numbers here. So if I roll a 2, if I roll a 3, if I roll a 4, a 5, or a 6. All right, your program's going to start getting pretty long here, but that is okay. I'm going to pull out the hardware again. I'm just going to duplicate it now. Okay, one more. Make that bigger so you can see what I'm doing. So if I roll a 2, I'd like these lit. If I roll a 3, let's do these. If I roll a 4, a 5. Remember, I'm making this mimic a number cube. And then if I roll a 6, I wanted to say 6. All right, so let's take a look at our program here. Make sure everything looks right. Repeat while true. Okay, as long as, ooh, I'm glad I checked. Something got changed here. So I have acceleration X. This should be acceleration Y. Acceleration X. Acceleration Y. That's easy to do. That's why you want to check your program before you hit start. All right, so whenever I roll, it's going to pick a number 1 through 6. If I roll a 1, 2, 3, everything looks pretty good. The only way to know for sure is to give it a try. Okay, so I'm going to move my book. code.Node's ready to roll. And I'm going to click start. Pick it up. 2, 1, 2. Wow, it likes 1s and 2s right now. 3. So I can see that my program worked. So whenever you pick this up and put it in movement and then lay it flat again, it's going to give you your number. So now you have a digital number cube. I'm going to bring you back to when we were talking about frequency of events. So I talked about rolling the number cube 20 times. I have a 1 in 6 chance for each one, which means 17% chance of rolling a 1, 2, so on and so forth. If you increase these events, you're going to see that these numbers, these percentages here, start to level out. So yes, I really did do this. I took my number cube on my code.Node and I rolled it 300 times. And when I did that, you can see how these numbers all started to get pretty close. 16% for a 1, 15 for a 2, and then I had a couple 18s with 3 and 5. So this is a really neat thing you can do when you're looking at probability of events, likelihood of events. You can also look at the frequency of those events to see if you see some interesting patterns. This has been probability. Good luck with your program. If you missed anything, don't worry. That's what the video's for, or you can refer to your book. Have fun.